Good morning, afternoon, or evening, wherever and whenever you are. My name is Ben, and welcome to part 5 for our Godot for YouTube Action RPG series. In this video, we're going to be adding a knockback state to the bats. We're going to be adding collision hitboxes and hurtboxes. We'll give the player iframes on their roll, and the player will be able to take a hit. Each entity in the game will have stats. The bats can take 3 hits, the player can take 4 before they die. And in order to accomplish these things, we're going to be learning about custom nodes inside of Godot. We'll create a custom hitbox node and a custom hurtbox node. And we'll also be learning about custom resources. So you can see right here on the player, we have our custom hurtbox and custom hitbox nodes. And then on the player, we have the custom stats resource, which is a resource that can be used to give stats to anything in your game. So I hope you're excited to learn these things. Let's jump right into the video. It's time to add the bat enemy to the game. We'll make a new scene. Come over here, click the plus button. Now I'm going to challenge you to set up the bat enemy scene on your own. You'll need to figure out which nodes to use, and I'm not going to have you do all of it, but I'm going to have you do the basics. So here's what you're going to need. You're going to need a node that will allow the bat, as a root node that will allow the bat to move around in the game, collide with other physics objects. Then you're going to need a node that will allow you to display the bat's texture. You're going to need a node that will give the bat a shadow. You'll need a node for animating the bat, a node for creating the state machines that will be used for those animations. So I'm going to let you try and do that on your own, and you can pause the video right here and try it, and then we'll do it together, and you can kind of make sure that you did it correctly. Okay, here we go. Let's start together. I'm going to do other node, and we're going to need a character body 2D for our bat. That way we can move it around and collide. We'll call it bat. And let's put enemy at the end. Save. I'm going to save this under enemies. Now we're going to need a sprite. And we'll grab our bat sprite right here. Texture. There's 1, 2, 3, 4, 5 frames. So come into the animation, and for each frame, set it to 5. I'm going to use an offset here, but you could also potentially just move the sprite up. I'm going to use an offset of -8 maybe. That might be a little high off the ground. Let's do -4. That's probably good enough. And then we're going to add another sprite. This will be for the shadow. Type shadow down here. We'll do a small shadow, just like that. And because of how I've positioned it, it doesn't really matter, but we do want this to do show behind parent, just like that. Now we're going to add a new animation player. And on this animation player, we're going to set up a couple animations. We'll start with an idle animation. Well, let's just make a fly animation. And we'll come to our sprite. And we'll come to animation. And then we'll keyframe 0. And I want to set this to 0.1 and zoom in just a little bit. Turn on snap. Key. And then we'll make it 0.5 in length. This might be too fast. Oh, we want it to loop as well. There we go. That doesn't look too bad, actually, speed-wise. And now we have a basic bat scene. Oh, but I actually forgot to mention this, so if you forgot it, it's okay. But maybe you remembered. We need to add a collision shape. And we'll just going to do a circle. Turn off snap here so I can get a size that I like. I might move it up just a little. I'll hold Alt and just move it up just a little bit like that. That should be pretty good as far as the collision shape goes. Make it round. And then we'll save. Now we'll start setting up our states. We're going to need to add an animation tree. Here, I'm going to move up the collision shape as well. And inside of this animation tree, we'll create a new node blend tree as our root. We'll select the animation player. Make sure you do that. And for the advance expression, we're going to make sure to select the bat enemy for the advance expression. Then we'll come into our animation scene tree here, and we're going to set up a state machine. So we'll add a new node, and we'll do state machine. We'll drag this connector right there. Now we've got a state machine. We'll come into our editor, open this up. Now our bat, a lot of games like this, in order to save on development time and costs for making art, a lot of games like this will do 4 directions for the main character, or even more than that, like potentially 8 directions for the main character, but then they will do only 2 directions for the enemies. And we can do that by just mirroring the enemy sprite, and that's just to save on development costs and doing all the pixel art for it. If you look at games like Hyper Light Drifter, for example, you'll see that they did that. Most of their enemies only face left and right as they're moving through the world, while the player character has more direction that they can do. So we'll do that as well. We're going to add a new node. Let's see, what's this button here? A new state, I should say. And our state can just be an animation, because we don't have to do a blend space because we're not going in multiple directions. We'll just do fly here, and click select. There we go, it gets finicky. And then we'll go transition from start to fly. But we're not going to call this fly. We're actually going to, I can click that there. We're going to rename this. We'll call this idle. And then we're going to make another state. So we'll click create new nodes, and we'll do our fly animation again. But for this state, we'll call it chase. We're going to use the same animation for 2 states. And then we're going to transition from idle to chase, and back from chase back to idle. But our transition from idle to chase shouldn't be automatic. So let's select it. And in our advanced expressions, we're going to turn off automatic for now. And we can turn off automatic here as well. Eventually we will have them be automatic while we do an expression here to see if we can see the player or not. We can see the player, will chase after them if the bat has been aggroed. And we can save. We'll come to our bat scene here, add a new script. Call this bat enemy. That's good. We'll come into this script, and we'll want to get access to our sprite. Not the shadow sprite. Let's call this shadow sprite 2D. I want to get access to the sprite and to the animation player. Actually, just the sprite and the animation tree. Drag those over and drop. Got access to both of them now. And we want to get access, again, just like we did with our player here, where we got access to the playback. We're going to do that same thing. And in fact, I think we can just copy this. So I'm going to do Control C, come into the bat enemy and do Control V. Should get access to the playback. And we can do our physics process function here. And we can set up our states. So var state equals playback.get current node. And then we can do, did we do a match case for the player? I think we did, right? We used a match. Yep, we did. We'll do that same thing. Say match state, and then we'll have idle, pass, chase, pass for now. Oh, and then we want the one right here. There we go. Now let's take our bat enemy and put it in the world here. and the bat. That, drag and drop one into the world. I'm going to duplicate it and put one down here as well. Save and run the game. And we have the bat enemy, and our player can collide with them and kind of move around them like that. Now we may not want that. I'll show you later how we can change that. But for now, we've got our bat enemy inside of the world. And we're ready to start adding in the logic for when it should aggro and chase the player. To write the code that will allow our bats to aggro and chase the player, we're going to have to first give the bats a method of finding the player and making sure that they can see the player, that they have line of sight. And there are a few problems within that problem. And the first one is that our bats don't have any way to get access to the player in the room right now. Now, earlier I talked about how when you want one node to talk with another node, the principle is signal up and call down. And that's true within a specific scene, right? If we're in this scene right here, we can signal up and call down. In our world scene right here, that gets a little complicated because we might be adding or removing bats dynamically, and we may be adding or removing the player dynamically in this level. So how are we going to give our bats access to the player? Let's look at one way that you could do it that really only works if you have a specific level where you don't add the player to the level dynamically and you don't add the enemies to the level dynamically. So what I mean is everything in the level is already in the level to begin with. So if we were to do that, we could come into our bat enemy and we could actually, and we're getting the animation issue. Let's see, open an editor. I'd love to figure out how to solve this, right? This issue. Maybe I'll press play on idle. See if it's still going. It is still going. Okay, I'm just going to reload the project. Okay, I've reloaded the project. I'm never quite sure what that error is. It has something to do with the animation tree and saying that the state doesn't have the right. I don't even remember what the error is, but it's a Godot editor error. It's not an error in our code or anything. And restarting the editor seems to resolve it. Okay, but what we would do with our bat is we'd come into our bat here, and actually you could go into the player and we can give our player what's called a class name. We can call it player. So giving a class name to a script puts that script inside of the global scope and not in a way that you can just access this player anywhere in code. It's not like a global, it's not an auto load or anything like that. It just puts the type. And so we're giving our player a type in the same way that we can type a variable to make it a vector or something. We can now type a variable to make it of type player using this class name. And it also adds a custom node to Godot. So if we go to add a node, we can actually type player and we can see our player type under the character body. We're adding our own custom node, which is really powerful, and we'll be doing more of that later. But for now, what we can do is go back into our bat enemy, and we can actually come right here and we can say export var player and then do of type player, that, and save. I've got this exported variable. If we go back into our world, we can click on the bat and there's this little player and we can assign the player to it. And we can do that with this enemy as well. And that's one way of giving our bats access to the player. But again, this only works if the bat is already added to the world scene and the player is already added to the world scene. If you create a bat, say you have an enemy spawner that generates the bats into the world, then you can't do this in the editor because they don't exist in the editor yet. They get created while the game is running dynamically, right? So this solution can work in some cases, and it's actually a super good. In the cases where it does work, it's actually really good. And somebody else brought up the fact that with our grass, actually, right here, I have this hard-coded in. And if this path were to change, if I were to move the grass effect, then this code would break. It would no longer work anymore. Because this grass effect scene is loaded right here using this path, and this path is hard-coded. So they actually said that instead you could do an export variable as well. So you could say at export var grass, and I'll just do grass effect like this. And then you could do of type. Now what is this? This is a TSCN, so we could do of type packed scene, because that's what it is. That var export var grass effect. Now it's mad at us because we already have a grass effect, but now we can close out of, or we can delete that code there, and we can click on our grass. And because this is a packed scene and not a node that we need to get access to, we can actually, oh, how did it know? How did it know to get it? That's surprising to me. I thought we were going to have to drag it in. I'm going to do it anyway. What? It's like locked too. Huh. But yeah, I thought we'd have to grab this and drag it over and drop it to set it, but somehow I already knew. And somehow I also can't get rid of it. Oh, now I can. Oh, that was bizarre. I wonder if it's because they were named the same thing. And so then it like magically inserted in the preloaded into this. I don't know. That's weird. I've never seen that before. And I've been using Godot for a long time. Anyway, we'll drag it over and drop it. And now if we were to move this around, it wouldn't be a hard-coded path. So this is a better solution as well. So that was a great comment by one of the other students that brought this up. So we're doing a similar thing here, only we're actually getting access to another node in the scene rather than a packed scene, which is a resource and isn't actually useful to us in this scenario. Okay, so that's one way to get access to the player. However, again, if we were to create stuff dynamically, that doesn't really work. It's also kind of a pain to have to go through every single enemy and make sure and set the player on every single enemy that you put inside of the game. So that's kind of a drawback as well. So let's look at a different method that we can use. So this method uses Godot's it uses Godot's groups. So we'll come to our player and we'll go to groups, and we're going to add a new group with this little plus, and we'll call this group player. And we'll make it global. And the only reason we're going to make it global is because then Godot will have autocomplete. It doesn't actually have to be global, but it does give us autocomplete. Press OK. And you can see there's this group now. We can uncheck or check whether it's in the group. And we get this little icon telling us that this node is in a group. If we uncheck it, it goes away. And if we check it, it comes back. Okay. Once we've done that, we can go into our bat enemy. And inside of the code, we can write a function called get player like this. And this will return a player. We already have that class set up, so now we can actually make our function return that. And that will give us autocomplete on whenever we get the player. Then we can say var player, and we can say player equals get first, equals get tree, get first node in group, and then we have autocomplete here, player. Okay? And then we'll just return this, return player. You could do this all in one line of code, right? You could just return get first node in group. That would also work. In fact, let's just do that. This is a little excessive to create a variable and then assign it and then return it. We'll just do this. So we'll just return get tree, get first node in group. Now, my understanding is that groups use hash maps, so it's very fast to get access to nodes in that group. And there's some other functions available here. You can get nodes in the group, which just returns a list of all the nodes. But this is the best way to do it for a player, and we can easily get access to the player. Now let's give our bat a range here. So we're gonna give kind of like a sight range, how far they can see. Let's make an export variable here, and we'll call this export variable range. You could call it Aggro Range or something like that. And then I'm going to set it to 64 maybe. That's pretty close, but we may update this. I'm going to do 128 actually. And we can always change this later if we need. And then down here, I'm going to write another function called isPlayerInRange. We're going to return a Boolean because it's going to be either true or false. So by default, we'll say result. We'll set this equal to false like this, and then we'll just return result. And then in here, we can say var player equals get player. Now, this might return null if the player's already died, for example. And so we want to make sure, and we can actually auto cast this since our function returns a player. We want to make sure that the player actually exists, and there's a few different ways to do this. One is to just say if player is player, and that's just to check its type. If the player is of type player, then we know we found one. If it's not, then that means it's null and there weren't any players to find. So we can say if player is player, then we can check the range. So we'll say var distance to player equals global position dot distance to, and then player dot global position. There we can easily get access to the distance to the player, and then we can check to see if that distance is less than our range. So if distance to player is less than or equal to range, or maybe just less than range, result equals true. And I'm actually going to tab this over just to make it a little more clear. So there we can say if player is in range, by default we'll return false, but if we do find a player and the distance to them is less than range, then we'll set result to true and return true. So now we've solved two of the problems we need. The first one is to check to see if the player is within the range, or to find the player. And then the second one is to check to see if the player is within the enemy's range. We'll make sure this works. We'll start by coming and adding some code to our chase state. So we'll say var player equals get player. If player is player, I want to make sure that one exists. Velocity equals global position dot direction to player. Player dot global position. We can get a direction from our global position to the player's global position. And direction to returns a normalized vector. So it essentially just gives us a vector that is pointing in that direction with a value of 1. And then we can give our enemy here a speed. So if we look at how we did it with our player, we just did a constant. So we'll give our enemy a constant up here. Speed. We'll set it equal to, I don't know, 30. And then we'll say velocity equals global direction to times speed. That. So during the chase state, we're going to move toward the player. And we'll need to call move and slide. If there isn't a player, we'll just set velocity equal to 0. So vector 2.0 like that. So if a player exists, we'll move toward them. Otherwise, we'll set it to 0. Now this is only in the chase state. So our enemy starts off in the idle state. So they shouldn't move toward the player. So let's run the game and make sure. So there's our enemy. They don't move toward the player at all. That's okay. That's what we're looking for. And then we can actually use our is player in range inside of our animation tree. So click on the animation tree and come into here. And what we want is in the chase state, or in this transition from idle to chase, come into the inspector, and we're going to set an advance expression. Now what this means is, wait, didn't we do this in our player? I'll explain it just as review anyway, but I do think we did this inside of the player. Maybe not. Would be in the move state actually. Yeah, we did. We set up advanced expressions in the move state. Okay, so this is a little bit of review, but that's okay. And in fact, that gives a good opportunity for a challenge. So what you'll want to do for this challenge is use our isPlayerInRange function in the advance expression to get the enemies to automatically switch from the idle state to the chase state if the player is in range. Now, if you aren't quite sure how to do that, just try it. Just try. Even if you completely mess it up, give it a try. Because trying it on your own will, when I come back and show you the fact that you tried it on your own, you'll remember it better. So try it, pause the video, try it yourself. Now I'm going to do it. Okay, so first we need to put the expression in here, and we're just going to say is player in range. So that's the only expression we need. If the player is in the range, just call that function. And also make sure that your animation tree has the advanced expression set to the bat enemy. That gives context to where the function is being called from. Okay, we'll just call is player in range. And we need this to automatically switch from idle to chase if this expression is true. Okay, now we can come into here and we can have it switch back. So here we'll say not is player in range. So we're doing this. I think the word not works here. We'll find out. If not, we can use the exclamation mark instead. And now, if we're in range, the bats do chase us. Although I guess 80 is a lot farther than, or 128 is a lot farther than I thought. Let's do 64 because they just immediately came after us. Okay. We get close enough, they'll chase us. If we come out of the range, they stop. Perfect. So our bats are chasing us whenever we get in range. Now we haven't set up line of sight yet. And let's set this to 104 maybe. 128 was too much, but 64 is too small. And then the other thing we want to do is we want to flip the sprite so that the bat is always facing toward the player. And we can, there's a couple ways you could do this. We might be able to use flip H. Let me see here. In this case, we could use flip H to do it. I usually use the X scale of the sprite because flip H doesn't always work depending on what the texture looks like. If it's not perfectly centered on the texture, flip H can create like a jarring, kind of choppy flipping. So I do prefer to use the X scale. So we'll do that. What we'll say here is we'll just say sprite 2d.scale.x is equal to velocity. And we want to do this. I actually want to do this inside of here, right here, is equal to velocity dot x, and we'll say the sign of velocity dot x. So sign is a function that returns either -1 or 1 depending on the value you pass into it. So if velocity.x is -50, sign will make that -1. If it's +28, sign will make that 1. So it basically just returns 1 or -1. And so we can easily alter the x scale, and flipping the x scale on the bats will just make them face us like that. And we already have bats chasing us. Okay, so that's pretty good here. Next, we'll work on establishing line of sight. Before we set up line of sight, I want to address an issue here with our bats. You'll notice that when the bat comes down, it can almost attach to the top of the player. And when the player moves, the bat moves with the player, while also kind of pushing them around and preventing them from moving up and to the left. So what's happening here is if we go into our bat enemy and we click on the character body 2D, by default, Godot sets the motion mode for the character body to grounded. And a grounded motion mode is used and intended for platformers. And it will actually make that character follow or snap to moving platforms. So what's essentially happening here is that our player character is becoming a moving platform for the bat enemy, and the bat enemy is attached to that moving platform. And so we want to swap this from grounded to floating. And we also want to go into the player and, well, I guess we already did set it to floating. So good job, previous Ben, who remembered to set it to floating. And now we won't have that weird issue anymore. Of course, the bat can still kind of push the player and prevent them from moving, but that solves the issue with the bat snapping to the top of the player and following them around. Now it's time to start implementing line of sight. Come into your bat enemy, and we're going to do this using a raycast. A raycast is just kind of like a laser that shoots out from a certain point and looks to see it and toward a certain point, and it looks to see if there's anything that it detects between those 2 points. We can add a new raycast node to our bat enemy like this, raycast 2D, and there we can kind of see this visually in the editor. For now, we'll just set the X to something like 8 and the Y to something like 0. That can be kind of the starting cast out, and we'll save that. And then we're going to come into our bat enemy, and we're going to create a new function here called can see player. And in this function, we're going to take advantage of our raycast. So we'll need to get access to it, so we can drag it over, hold Control, drop. And we're also going to take advantage of getPlayer and isPlayer in range. So the first thing we want to do is we want to check to see if the player is in range, because if they're not in range, then we can't see the player. So if not isPlayer in range, return false. So if the player's not in range, then we just want to jump out of this because we can't see the player anyway, they're too far away. Next, we want to make sure we want to actually get access to the player. So we'll say var player equals get player. And then we can say if player is not player, return false. So again, this is another break where we're exiting out of our can see player function here if something's wrong. And essentially in this case, there's no player. So although technically is player in range, yeah, is player in range could, if there's no player, is player in range will also return false, right? Get player, yeah, it will also return false. So we technically don't actually need that. But I guess, I don't know, it feels weird to not have it in there as like a check. It's like an extra safety precaution that I just can't quite let go of, I guess. But it doesn't actually have to be there. Yeah, so I guess the right thing to do is to remove it, because we know that is player in range will return false. If not is player, yeah. We know that. Okay. Once we have the player, we can set the raycast. It has a property on it called target position, and we'll set that equal to the player's global position. So it's looking toward the player. And there's going to be an issue with this that I'll show you in just a minute. And once we've done that, we can say if, or we can say var, what should we call this? We'll call it is line of sight blocked, and we'll set this equal to raycast 2D.is colliding. So if it's colliding with something, we know that line of sight is blocked, and then we can say return not is line of sight blocked. Is that right? If line of sight is blocked, it would be true, and we can't see the player, so not makes it so that we can't see the player. So can't see player returns false, and if line of sight is not blocked, then not would make this true. Yeah, I think that's right. I don't like the kind of double negative feeling though, so what I'm going to do is I'm going to rename this variable. I'm going to name it player, or let's call it has line of sight to player, and we'll do LOS for short, and then we'll say not raycast is colliding, and then we can just return as line of sight to player, because if this is true, then we can see the player. I think the logic there makes more sense, and it'll be easier to follow. Now that we have can see player the can see player function, we're going to go into our animation tree, and we're going to go into our transitions, and inside of here, instead of using is player in range, we're going to use can see player. We have a more sophisticated function for determining whether we should chase the player or not. So we're going to update and start using that. And then we'll have the other transition here, not can see player. Okay, and save. Let's come back. Well, first, let's actually just turn on visible collision shapes. If you don't already have it on, turn it on. Because what we're going to see here is a problem. So, why isn't the raycast pointing toward the player? Well, what you're going to notice is that the raycast is actually, it's essentially, if you imagine that the origin of our world is right here, and you point an arrow in the direction of the player, you would notice that that vector looks exactly like going from the origin of the bat over to here. And that's because the vector, or the position on the bat, the position of our raycast is actually set to 0, 0. And this target position is actually relative to that 0, 0. And so if we get the player's global position, that's going to be basically the offset from the origin. And when we set the target position here, that's going to be the offset to from the bat. And that's not going to be what we want to get to the player. So instead, the math here, in order to get the correct vector, is actually player.globalPosition minus global position, which is the position of the bat. And that will get us the vector that we need, the difference, because we need the difference between the bat and the player in order to correctly set the raycast to go toward the player. And now we should see that that works correctly. But there's a problem here. The raycast is always returning colliding, so the bat never chases us. Why is that? Well, our player actually has a collision shape on it, right? So the raycast is just detecting that collision shape. And before it was working because it wasn't going toward, it actually wasn't targeting the player correctly. And usually raycast is smart enough. It has this property called exclude parent. So it was automatically excluding the bat from the collision detection, but it wasn't excluding the player. And this is where we need to learn about collision masks. So you can see our raycast here has this collision mask. And if we come into the player, we have this collisions properties with a layer and a mask. And our bat enemy has these as well. By default, they don't have any names to them, but we can name them. And if you just put edit layer names right here, it brings it up for us really quick. I like to name the first layer world, the second layer player, and the third layer enemy. And I'll often do other layer names here, but for now we'll just start with these three. And these layers determine how Godot decides which physics bodies should interact with which other physics bodies. And so we can manually determine whether or not the raycast should interact with the player versus interacting with the world versus interacting with the enemies. And in our current version, for example, you remember the player actually collides with the bats as well. So if we come into our player, let's talk about the layer versus the mask. The layer is the collision layer that object exists on, and the mask is the collision layer that it's looking to for anything that it should collide with. So right now our player is on the world layer. We want to move it to the player layer and take it off the world layer. But for masks, we still want it to look to the world. So when the player is looking for something to collide with, we want it to look to the world, just like that. If we come into our enemy, and click on the enemy right here, we want to set the layer to enemy, and we want it to look toward the world as well. Now for our raycast, we want it to look for the world and not for the player, which it's already set up to, by default, it's looking to the world as the collision mask. And raycasts don't have a layer because they can't actually be collided with, but they're looking to something to detect collisions. Okay, so now it should work correctly, and we do have line of sight. If we break line of sight, the enemy stops moving toward us, like that. And if we have both of our enemies come toward each other, you can see that they can actually start to overlap each other. And this can start to look kind of weird. But if we go back into, and also with the player, since they can now overlap the player, they get kind of jittery right as they go over the player. So if we go back into the collision masks for our bat enemy, we can also have them look toward their own layer for collisions. And we can have them look to the player's layer for collisions as well. And for the player, we can have the player look to, there aren't other players, so it doesn't have to look to its own layer for collisions. We can have it look to the enemy layer for collisions as well. And so now the player can no longer run through enemies, and the bat enemies also will collide with each other, and they no longer overlap in weird ways. And we have line of sight correctly working as well. Now later in the series, we're going to set up a system for the enemies to be able to move around trees. And what we'll be using for that is what's called a navigation mesh. And the navigation mesh will allow the enemies to be smart enough to move around objects in the world and chase the player. That's going to be a little bit more complicated, so it's going to be just a bit later in the series. And we'll also make it so that enemies don't exit out of the chase state once they lose line of sight. They'll continue to chase the player even if they lose line of sight. They just won't chase the player anymore if the player has gone out of their max range. And so that way, if an enemy sees us and is chasing us, we move behind a tree, it won't stop chasing us. It will continue to move around that tree and chase us using the navigation mesh for its pathfinding and come after the player. But if we get far enough away, then it will stop chasing us anymore. And that's going to be the next step for the artificial intelligence for our enemies here. For now, though, this is a pretty good place to stop with the artificial intelligence, because we want to start adding in things like attacking the enemies and the enemies being able to hit the player and being hurt. And we can test all of that stuff without setting up the navigation layer stuff quite yet. It's time to add some hurtboxes to our enemy bats. Let's come into the bat scene, bat enemy scene, and we're going to add a new area. Call it area 2D. And for the bat, I'm going to we'll add a collision shape. Now you could use a collision polygon if you wanted this to be exact, but for small enemies, often you don't really need to do that. Just use a circle, shrink it down, maybe about here. That looks pretty good. And I actually think I want to move the bat sprite over by a single pixel. Or I could adjust the offset as well, because we did -4 in the Y on the offset. So let's actually set the transform back to 0 and just do, I think it would be +1. No, it's -1. -1 on the offset for the sprite. Okay, so we've set up our hurtbox. Now we can come into our bat enemy and we can get access to this, and then we can create a ready function. And inside of the ready function, we can say area 2d.area enter.connect. Then we can call a function, and this is going to take another area. So we'll say other area 2d. Will be a type area 2d. We're writing this function inline here, which I don't think I've done yet, because in the grass, it's getting mad at me here. In the grass, we connected directly. We didn't even connect to the signal in code here. That was actually the grass effect. In the grass, we did connect. In code, we connected to a pre-made function on area 2 entered. And we could do that as well here. But for now, just for the sake of example here, I'm going to write this function in line. And so this essentially allows me to create a function without ever naming it. Call it an anonymous function or a lambda. So it's calling it down here. And then we can just call Q free. So the bat dies whenever this area is entered. Now you're going to see the problem with this pretty quickly here, because if we get our bat to start chasing us and then it touches the grass, both the bat and the grass destroy each other. And that's a problem. We have areas on the grass and areas on the bat, and both of them are looking for another area and trying to determine if they should be destroyed when they collide with another area. And since both areas are on the same collision layer, right here on the world layer, they are overlapping. Now we could just try and do the layers here, but I like to start thinking about these hitboxes and hurtboxes in those terms. So a hitbox, it would be the sword, right? Our player's sword would be considered a hitbox, because it's swinging and it's intending to deal damage, and we want to be able to calculate damage. So a hitbox needs to know how much damage it's going to deal. And then the hurtbox is going to be taking that damage, receiving it, and doing something with it, or emitting out a signal and saying, hey, look, I took this much damage. And so thinking about it in those two different terms will help us to separate these areas. Now, in order to do this, what we're going to do is actually create custom nodes inside of Godot. Godot allows you to extend their built-in nodes and create custom versions of them. So we're going to take the Area 2D class and we're going to make two child classes, a Hitbox class and a Hurtbox class. So in our file system here, I'm going to do create new, and I'm going to create a new folder and call it damage boxes, like this. And inside of here, I'm going to create new, and I'm going to create a new script. Now this script isn't attached to any node currently, and we're going to have it inherit from area 2D. And we'll call this first one Hurtbox, just like that. We'll create it. And we can come into damage boxes, and we're going to give this a class name. This is how you create a custom node, because you can extend a node, but that just makes it so this single script extends that node. If we add Hurtbox right here, do class name Hurtbox, and we go to create a new node, and we type in Hurtbox, look at that. Here's our own custom node that we have created that is a child of area 2D. So it has all of the functions and signals and variables, or I guess properties of area 2D, but we can extend it. We can add our own stuff to it. Once we have the Hurtbox, we're actually going to right click on damage boxes, do create new script. We're going to create a hitbox as well. And we'll call this one, it will extend area 2D, just like that. We'll create that script, come into it and do class name hitbox. I'm creating both of them because they will reference each other. That's one of the ways we can determine whether or not we should take damage from another area, is whether or not that other area is a hitbox or a hurtbox. Now we can start by taking our hitbox and giving it a damage value. We're jumping ahead just a little bit here, but that's okay. We'll say export var damage. We'll set it equal to 1 by default. So now our hitbox has a damage property. And if we were to come into our player and we were to click on our area 2D right here, we can actually convert this area 2D into a hitbox by just dragging our script onto it, just like that. So now this area 2D is a hitbox. Or we may even be able to right click on it and do change type, type in hitbox, and there we go. And I think that's actually the better method. Godot recognizes it as that type of custom node now. You can see the difference because the script here is kind of faded, indicating that it is a custom node that we've done in the scene. So we'll call this sword hitbox. I mean, we could probably just call it hitbox. It's the only one, hitbox. And you can see our damage property over here. We can leave our damage set equal to 1 for now, but this could be a way that you can increase the damage if the player were to get a different type of weapon, for example. Of course, I don't have the sprites to indicate other weapon types, but if you did, then you could increase the damage here and swap out the sprite whenever the player got a new weapon. Now we want to start setting up our collision layers for this because it's still just on the main layer here. So we're going to click this little thing here and we're going to do edit layer names, and we'll create one called player hurtbox, and we'll create another one called enemy hurtbox. Now layers 4 and 5 are enemy hurtbox and player hurtbox. So this, on our player hitbox here, we'll put the player hitbox on the enemy hurtbox layer, which is 5. We'll do just 5 and 5. We'll do it on the layer and the mask because I actually want to try something a little different. In the past, I've usually put hitboxes only on the mask, but I'm going to try something here. Once we've done that, we can go into our grass and we can click on our area 2D in the grass scene. We can right click, do change type, and do hurtbox, just like this. Now our hurtbox is going to need a ready function. So let's give it a ready function. And it's going to connect to its own area entered signal. So we'll say area entered dot connect, and we'll connect to an on area entered function, and then we'll make this function. Okay. On area entered. Now it needs it's going to be receiving some sort of area, right? So we'll say other hitbox of type hitbox void. And then right here we can just say, you know, this could be an area. Let me think through this here again. We can say if other hitbox is hitbox, return. But we're going to say is not hitbox. And then we're going to create our own signal. So we can create our own custom signal here. So we'll say signal, we'll call it hurt. A hurt signal, and it will emit out a hitbox. So hitbox, this. And yeah, I think it makes sense to make this area 2D just to keep things simple. Area 2D, and it'll be of type area 2D. We'll do an underscore here. And make sure that's lowercase. If area 2D is not hitbox, return. Okay. So we've set up our little check here, and then we can say it, and then we can say hurt dot emit, and then send out the area 2D because we know it's a hitbox. Okay, so it's only going to emit this signal if it's a hitbox. Now we can click on our area 2D here, and we can name it Hurtbox on our grass. And we already connected to it. But now, since we're changing the name here, this is going to change. I'm going to just drag it in again, like this, and get rid of this one. And then call this Hurtbox. And then do hurt this. And we'll call this on hurt. And call this on hurt as well. And we'll call this other hitbox. And we'll call this hitbox. Okay. So we've just kind of refactored the code a bit. And the reason I showed you the on area 2D with just a normal area 2D to begin with was to show you kind of the logic for setting up signals. But now we're getting slightly more complex scenarios where we might have a bat area overlapping the grass area. How do we distinguish when they should be damaging each other, how much damage they should be doing, whether they should even be receiving those signals? And that's where the hurtbox and hitbox distinction comes in on our areas. Now we also need to go in and set the collision layers for this to the layer and the mask both to the enemy hurtbox layer. Now our player's sword should detect this area, but the bat, and we still need to convert the bat, but its area should no longer detect. So let's come over here and see if we can get the bat. And there we go. It's no longer destroying itself because the detection is only looking for hitboxes now, right? If it collides with another area, if the hurtbox on our grass collides with another area, and that area happens to not be a hitbox, then it just exits out. It just returns out of the function, doesn't do anything. So that's looking pretty good. Let's convert our bat now. I'm going to come in here, right click, and do change type. And we'll call this hurtbox on the bat. And we'll set it on for the collision layer. We'll need to set it to 5 as well for enemy hurtbox. And then inside of here, we need to switch this up. This is all wrong. Again, call this hurtbox. Delete this. Drag this in. Hurtbox. Hurt. Then we're going to connect and we're going to expect an other hitbox. Hitbox. And we'll still queue free. So now, can the player destroy the bats? That's the question. The answer is yes. The player can now destroy the bats. And the bats, even though they're on the same layer as the grass now, no longer destroy the grass when they move through it because the bat has a hurtbox on it and the grass has a hurtbox on it. So they won't detect each other because they're ignoring other hurtboxes. They're only detecting hitboxes. Now, if you wanted to be especially performant, you could actually only put the hurt boxes on the layer and the hitboxes on the mask. And that makes it a little bit more performant, but it's a very small change. And then you would have to, because of the way that layers and masks work, you would then have to have your hitbox detect the overlap, and your hitbox would have to detect the overlap and then call some sort of like hit function on the hurtbox, like take hit function on the hurtbox. That's what I've done in the past. You can actually check that out in my Ninja Platformer series where I do that exact same thing. But in this case, I think it's better to just go with this approach because it simplifies the code quite a bit. We're looking pretty good here now though. The next steps are going to be adding stats to the enemy bats so they don't die in one hit, and giving them a knockback state so that we can hit them with a sword and kind of knock them away from the player. And then we'll start working on adding hitboxes on the bats and a hurtbox on the player. Let's start with the enemy knockback state because I think that will make things a little bit more fun when we're hitting the enemies. So we'll come into our bat enemy right here. We'll come into our animation tree. And inside of here, we can do open in editor. And we only have the idle and the chase state. What we're going to do is we're going to add a new state. So we'll do this little plus, and we'll use an animation, and we'll just do the fly animation. You could create a hit. You could create a hit animation specifically, but we'll just do fly. We're going to select this, move it, and I see that I just named it idle and chase. Oh no, I didn't. Did I? I did. I'd actually prefer to name these state. And we'll name this one hit or knock. Maybe hit state. Yeah, we can do hit state. Now the hit state is going to transition at end and automatically back to the idle state. This. And we're not going to have anything that transitions to the hit state because it's going to be easier to just skip any sort of traveling and just immediately set our state to the hit state, no matter what previous state we were in. And so because of that, we don't need to create any transitions from the idle or from the chase state. We're just going to manually encode jump right to the hit state. Although this says at end, and I realize that that's going to transition back when the animation finishes, which we don't want to do in this case. So we'll select that transition, and we'll just make it immediate and auto. But we're going to set an advance expression. And if we come into the bat, or if we come into the animation tree, we did set the advance expression base to the bat enemy. That's important so that it knows which context. We did do that already. That's good. And we can check this. And what we're going to do is we're going to say velocity is equal to vector 2, 0, and 0. This. So when the velocity reaches 0, it will transition back from the hit state to the idle state. And actually, I said we weren't going to make an animation for this, but I actually want to. Let's come into the animation player. We'll create a new one, call it hit, and we can just take our bat. I think it could be interesting to find a frame, maybe this frame. Yeah, I kind of like this frame right here for taking a hit, or maybe this one. Let's do frame 3. We'll key that. There we go. And I want to set this to 0.1. So why am I creating a hit animation? I'll make it 0.2 long. The reason I want to create a hit animation is because I actually want to, I'll show you in just a minute. I'll show you later, but we'll just do it for now. So just trust me for a bit. Let's come into our animations and we'll click on hit state, and we'll change this to hit instead of fly. There we go. Now, our hit here, we can come into the bat enemy, and we want to change this to idle state, chase state. Now we can add the hit state, this. And in the hit state, we're going to call move and slide. And we're also going to approach 0 with some friction. And we can do this pretty easily by just saying velocity equals velocity dot move toward vector 2.0. And then we need to give it some sort of value to approach 0 by. And for now, we'll just, well, let's make a constant here up here. We'll say const friction, set it equal to, what should we set this equal to? 500. Start with 500. And then here we'll just say friction times delta. And you might be like, Ben, wait a minute. I thought you said that move and slide automatically applies delta. And so when you're manipulating the velocity, you don't actually have to apply delta. Well, that's only when you're setting the velocity. Move toward is an acceleration. So move and slide, velocity is our change in position over time. And move and slide automatically applies delta to our change in position over time. This, however, friction, using the function move toward, represents our change in velocity over time, which is an acceleration. Friction is a type of it's a deceleration, but acceleration, right? It's a change in velocity over time, not change in position over time. We have to multiply this by delta. Otherwise, our change in velocity over time will be frame dependent and not time dependent. And that would be really weird because our change in position over time is time dependent automatically because of move and slide. Okay. There you go. So we have this hit state. Now how do we enter it? Well, our hitbox is going to need some additional information. So if we come into our hitbox, we're going to add a new export, and we'll set this to vector, or let's see, this will be a vector 2. We'll call this knockback direction equal to a vector 2, just like this, and we'll export it. Okay, so we have this knockback direction now on our hitbox. Inside of our bat enemy, when we take a hit, what we can do is we can say, instead of freeing the bat, we can say velocity equals other hitbox dot knockback direction times 100, and then we can say playback dot set, or let's see, dot start hit state. Okay, playback dot start hit state, and we'll add a print here, changed to the hit state. Okay. Now the knockback direction is currently set to 0 on our player's hitbox, right? We can see here knockback direction is 0, 0 in the editor. What we can do is when we update the input vector here, we could actually update the knockback of our hitbox. If we grab our hitbox right here, drag it over, hold Control, and inside of here we can say, well, we don't want to use the input vector though. For now, we'll use the input vector. Hitbox dot knockback direction equals input vector dot normalized. Get the knockback direction that way. I think I have an idea for how to do this better, but we'll do that in just a second once we confirm the other code that we wrote is working correctly. Okay, so let's run the game and try attacking the bat and see if I forgot anything. Oh, that's roll. Okay, so we're not even hitting the bat right now. Well, actually, we are hitting the bat. It says change to hit state. So I know what's going wrong here. So this is a timing issue, and it's a little bit difficult to describe because timing issues can be... learning to solve timing problems requires a deeper understanding of how the engine works underneath, how Godot processes stuff. The physics process in Godot is designed to process any physics events. And our Hurtbox here is an area 2D, which its overlap stuff also is designed to process physics events. So they're kind of in the same timing, except that what ends up happening here is that we try to start the hit state right here, but then we jump into the physics process and we get the current node, and current node hasn't been updated to the new hit state yet technically, and so it just sets the state to chase state. And then in here, it kind of messes up everything we just did. It messes up the velocity. Our velocity becomes 0, or our velocity becomes whatever if it's moving toward the player. So this is a weird timing issue. And the way that we can solve this is by using what's called call deferred, which just defers a call. It makes it wait till the end of everything else being processed. Let's create a new function here. And we'll call this function take hit. And it will take other hitbox. It will take a hitbox like this. And we'll just copy this code right here. Control X, Control V. We'll copy this code into this function. So we have this take hit function. Now up here, when we connect to the hurt, instead of doing this anonymous function, we can just call take hit. And that would take underscore hit. And that would automatically do what we were doing before, but now we've named the function, right? But if we put .call deferred here, now this function will actually be called at the very end of after everything else has been processed in the current frame. And that timing will allow us to correctly get the right playback, get the current node on our playback after doing it. So let's see if this works. Okay. Yep, and there we go. Now you can see there's a little bit of knockback, although we may need more. Now we can get the diagonals if our character is moving at the diagonal because it's using the input. And again, that knockback amount is pretty low. Now we may want to put the knockback amount inside of our hitbox. So we could export our knockback amount equal to 200. Set it to 200 by default. And then if we come back into our bat enemy right here, when we take a hit, we can multiply the knockback direction by the other hitbox.knockback amount. So we can actually set the amount that the knockback, how much it'll affect the bat. Now if we come into the player and we go into our animation player, we can actually go into each attack. So attack down right here. Well, click on AnimationTree and then animation and then attack down. Now right here, we can actually set some properties on our hitbox because we exported them. We can put them in our animation. So let's set the knockback direction to 1 in the Y and 0 in the X. That's down. Now the knockback direction is down on attack down. Now I'm going to pause this and set all the others, and you can do it. Well, I'm going to pause the recording and then set all the others, and you can do it as well. Pause the video. Okay, so I set the knockback direction. Probably want this to be discrete as well, although I don't think it will actually matter because we only have one key, and it's just gonna jump right to that key when we change animations. Then we can go back into the script and turn off how we set up the knockback amount in here. I just don't want knockback to ever go on diagonals. And in the way that we were doing it, it could. This will only allow knockback to be on the cardinal directions. There will be no knockback in different diagonals. This is feeling pretty good. There's one last thing that we need to do here. Watch this. That's a problem, right? If I just hit one enemy, it kind of tries to knock back and freezes the other one and creates weird issues. So, remember when I said I wanted to have an animation for the bat enemy for being hit? Here's why. It allows us to go into our bat enemy scene here, and we can actually, on the very first frame of hit, we can actually key taking the enemy off the base layer. And once we get it back on over here, at the end of the animation, we can key it being back on. And we'll need to update reset to make sure that it's actually on layer 3. So I went into the reset animation and put it back on layer 3 in the reset. Let's see if this works. But ideally, it should allow the enemy during a knockback to travel through the other enemy. Oops, that's if I can. And it's not. And that's probably because I just got my layers and masks messed up, which is pretty normal. So we'll come back into hit. And so we want the enemy. Do we want to remove it from both? Yeah, we want to remove it from both, I think. We want to remove this and key it. And then come to the end here and put that back in and key it, I think. And then go into reset and make sure that it's on in the reset track. Let's see if this works. Come on, bats. I always roll. There we go. Now during knockback, they can actually travel through each other. Now if they end up kind of in the same spot during a knockback state, you may end up having them kind of pop out of each other just a little bit, but it usually looks pretty good with this approach. Allowing the enemies to collide with each other, except when they're in the knockback state, then they don't collide with each other. Yeah, see there, just like that. There we go, looking pretty good. We just learned how to set up a custom node in Godot for our Hurtboxes and Hitboxes. Now I'm going to teach you how to set up a custom resource. And this custom resource will be useful in creating stats for both the player and the enemy. Let's come over in the file system and right click, and we're going to create a new script. And we'll call this stats. And instead of inheriting node, it's going to inherit resource. This to create. And we can go into this and we can say class name stats like this. And we'll give our custom resource some properties. We'll say var health equals 1, var max health equals health, and we'll export this. So we'll say export var health, and we'll export this as well at export var max health. So we'll actually just set them both to 1 like this. We've got our health and our max health. And then inside of our setter here, we'll make a setter for export health, and the setter function will just allow us to, whenever the health changes, we can check to see if we don't have any health left. Essentially, a setter function is just a function that runs whenever that variable changes. We say set value, then we'll say health equals value, just like this. Now we want to check. We're going to make a signal here, custom signal, and we'll call it no health. And then we can just say if health is less than or equal to 0, no health dot emit. That. And you could make it do this only if the health has gone from a value above 0 to then a value below 0. There may be cases where you want to do that. I don't think we need to in this case, so I'm going to start off by will not solve that problem unless it presents itself. So we have health and max health. Enemies probably won't even use max health, but there we go. We've created a custom stats resource. Now, what can you do with custom resources? Well, you can create them here in the editor. So we could do create new resource. We could type in stats, and we could create a new stats resource. And we'll just call it new resource for now. And we could edit it right here in the editor. Set it to 5 and 5. We could rename it so it's called like player stats or something like that. Pretty cool. Custom resources are amazing. But we're not actually going to use any over here in the file system. What we're going to do is come to our bat enemy, and we're just going to export its stats right here in the script. Export var stats of type stats. Now, if you set the type, when we click on the bat enemy and we are editing our export variables, we can actually do new stats, and we just have stats here. We'll give our bat enemy 3 health. They won't be able to heal, so they don't really need max health, but I'm just going to set it to 3 as well, just because. There we go. So our enemy has 3 health. And now, whenever we take a hit, here, we can say stats.health minus equals other hitbox. Awesome. Or other hitbox.damage. Awesome. Once we've set that up, we can come into our ready function and we can say stats.nohealth.connect queue free. This is looking, and we don't want those parentheses. That would call the function, not actually pass it in. This is looking pretty good, right? We love this. This is very clean code. We export the stats, we set the stats, we subtract from the stats when we take a hit, and we free the bat whenever there's no health left. Now, you can tell by my tone that we're probably going to see the problems with this. But here we go. Okay, 1, 2, 3. Wait a minute. Where'd the other bat go? They both died. That's because resources inside of Godot are shared by default. And so that 3 health that the bat has is actually this shared stats variable across all bats. So whenever you hit one bat, all of the bats, they have this hive health. All of the bats, all of their health, well, I mean, it's the same health object, right? They're all sharing the same health object. So when that health object gets set to 0, it emits out the signal saying no health's left, and they all get that signal and they all die. So how do we solve this problem? Well, we want the stats to be unique to each enemy. And I have found that the most reliable way to do this is just in the ready function to say stats equals stats.duplicate. That just duplicates that resource so that every single bat has its own instance of the stats resource. You can also, in the resources, they also have this property called local to scene. That can work in some places, but I have had mixed results with that. So I prefer this method because I understand it and it works for me consistently. Now, we can go attack our bats. And 2, 3. And now it only kills one of the bats. So, pretty cool. Pretty awesome. Real quick, I just want to explain why are resources shared. It seems kind of annoying in this example that I just gave, right? having to duplicate it. Why is it shared? Well, it can save a lot of memory. For example, textures are resources. So every single bat enemy has this same, every single sprite for the bat uses the same texture. If I were to edit this texture in a sprite editor, it would update the texture for all the bats, right? Because it's shared, and that can save memory. So there's a lot of benefit to sharing resources, and most of the time it makes sense to share resources. But in the case of stats, it doesn't make sense. We want them to have for each of them to have their own individual stats resource, and that's where duplicate comes in. Now we can also give our player stats. Let's click on our player. Here, go into the script, and up. We're exporting variables up here. We haven't exported any yet, but we can export. We can say var stats, and then our player, we can just do new stats. Now when we do new stats here, this creates a new stats resource. So this stats resource is actually different from the bats because we just made a new one. Okay, we set the health to 4 maybe, 4, like that. And we don't have any hitboxes or hurtboxes set up on our player because we still need to set up that kind of stuff. But now our player has their own stats as well, and we can use that same stats resource or that same stats custom resource that we made for anything in the game that needs to have stats. And so it's very reusable component type thing. Well, there you go, and we're looking pretty good with our stats. Now we just want to look at adding a hit to the player and then giving the player a hurtbox and the enemies some hitboxes as well. It's time to allow the player to take some hits. Now, it's going to be a little different from the way we set up the enemies. For the enemy, for the bat, we set up a specific state for taking a hit. And the reason we did that is because the bat enemy actually loses control during that hit state. However, the player, we don't want the player to lose control. We want them to continue to be able to move their character. We want to give them some invincibility frames, and we're going to make them blink. Their sprite will blink during those invincibility frames after they take a hit. We'll come into our player, and in order to do this, we actually want to create 2 animation players. And the reason is because we want to be able to overlap this blink animation on top of whatever other animation is currently being played. The player's running or attacking or rolling, we want the blinking to happen no matter what. And so in order to do this, we have to add a new animation player node that will handle blinking, and then this animation player node will handle the other attacks. So we'll create a new node here on our player. We'll call it animation player. And we'll call it blink animation player. Or you could call it effect animation player, something like that. I'm just going to create a new one. We'll call it a new animation. We'll call it blink. Set this to 0.1. And we're going to animate the player's sprite. We'll animate the visibility property. So we'll turn off visibility first, key that. Go over 1, turn it back on, and key that. Now we should be able to copy these, I think. C, V, V. And how many iframes do we want? 0.1, or not 0.1, 0.5. This, let's see if it works. Okay, so we do get some blinking. I'm going to turn on the loop. Okay, it doesn't give enough time in this last one, but I think that's actually fine because we're not going to have it loop. Then we're going to come into the reset and make sure that this is actually on because it's off by default. Okay. Reset. There we go. We have a blinking animation. The other thing we can do is we can make our character invincible during this blinking animation. Currently, they don't have a hitbox. We want to add one. Click on the player, add a new hitbox. Or no, hurtbox. They don't have a hurtbox. They do have a hitbox. And then do a new collision shape. And I'm just going to do rectangle, I think. I want to set this animation to be stand down. So I can kind of position this hitbox a little better. Do something like, we don't want the head to really hit stuff because of the perspective that we're in. It's going to be a little up to you how you want to set up the hitbox for the player. I think it's something like that, kind of just around their body, but not on their head. That way, if we run kind of past a bat and it's up here, we won't necessarily hit it right there. If it gets down far enough into the character, it will hit them. I think that makes sense. So you could manually add an invincible property to your hitbox, and we could have the blink animator, the blink animation player actually manipulate that property, that invincible property. But reorder these just a little. I don't think that's necessary because we can actually key the disabled property on the collision shape of our hitbox. So just key disabled, and then at the end of the blink animation, we'll turn off disabled and key it back to normal. And we'll go to our reset and make sure that it's not disabled by default. If your reset track has it disabled by default, you may find that your player is always invincible. We don't want that. Okay, so we have a hitbox. We're going to come into the collision layer and we'll put it on the player. We'll move it to the player hurtbox layer and mask on player hurtbox. Now we can come into here and inside of our player, create a ready function. Oops. Ready. And we'll drag over our hurtbox. And we'll actually want to drag over blink animation player as well because we'll need that. And in our hurtbox, we'll just say hurtbox.connect. And we'll connect to a take hit function. And we'll make this take hit function. Take hit, it will take a hitbox. We'll call it other hitbox. Why are we calling it other hitbox? Well, because we already have a hitbox, although we aren't getting access to it in this script. In the future, we may decide to get access to it. So other hitbox, type hitbox, and then we'll just say, well, we can say stats dot health minus equals other hitbox dot damage. We can say blink animation player dot play blink. And there we go. Hurtbox.connect. This is wrong because we're connecting to the hurtbox.hurt signal. Hurtbox.hurt.connect. Just like that. Okay. Now, our enemies need a hitbox though. Our player can't take any damage from them if they don't have a hitbox. So we'll come to the enemy, add a new hitbox, just like this. We'll make sure to set the collision layer to the player's hurtbox and the collision mask to the player's hurtbox. We'll give it a collision shape. Oh, that was not right. I did not do a collision shape. There we go. Collision shape. I'll just do another circle. I'm going to move this up. I'm going to make the collision hitbox basically the exact same as the hurtbox. And then I want to point out real quick that you can set the color on these collision shapes. So I could make the hurtbox blue and the hitbox maybe red or something. Now they're overlapping, so it's kind of hard to tell, but it could be useful to do that. So you might consider it. Okay, now we should be able to take a hit. And there we go. We do. We take a hit from the bat. And we're not connected to no health, so we'll have to connect to that. And also our player can still run into the bats, which doesn't really make a lot of sense. So we'll have to address that. Also getting an error message here. It says can't change state while flushing queries. Wants us to use call deferred. So we'll do the same thing that we did. We'll say take hit dot call deferred. Just like this. And let's go into our player. Let's make it so that they don't detect the enemy layer. And we'll go into our bat, click on the bat, and make it so they don't detect the player layer. Oh, I keyed that. And let's see. Oh yeah, that's just the other error we already fixed. So it's not letting me remove this because it's actually keyed in our animation. We come into the hit and we look at the collision layer. Sorry, the collision mask. See, we have the player layer keyed. We want to make sure that it is not keyed in either of those. And in the reset track, make sure the player layer is not keyed. Well, and again, that is for the bat character body 2D specifically, because our character bodies have collision layers and our hurtboxes and our hitboxes all have collision layers. So keep that in mind. When I'm removing these so the player can move through the bat, not from the hurtbox. There we go. Our player can move through the bat. They can attack the bat. Let's see if we can set up allowing our player to die. So we'll come into the player. In the ready function, we'll say stats.nohealth.connect. And then we can just call queue free. See how this works. A hit, take a hit, take a hit, and we die. Now the problem is that just freeing the player creates some issues because our camera jumps clear over here because the camera is attached to the player as well. So what I recommend in this case, when you have a camera attached to something, is instead of freeing that object, it's easier just to disable it. So let's create a new function called die. Oops. And inside of here, we'll say all nodes have this property down here called process, and by default it's set to inherit, which means it will copy whatever the process property of the parent is, and by default the scene tree is set to always process. Or actually, it might just be pausable. So this can affect when you're pausing the game as well. But if we just do disabled, that will just completely disable this node, so it can't do anything. We can completely disable the player. So we'll say process mode equals process mode disabled. This, and instead of calling queue free, we can call die on the player. Then we can take a few hits from our bats. And our player is now, I mean, you can see their shadow still, and the bat is kind of freaking out because it's trying to move toward the player still. But we can also hide the player, and we could probably remove it from the group too when it dies. So we'll say hide, and then we'll say remove from group player. That looks good. So just kind of get rid of it. And there we go. Now the bat's not freaking out anymore because the player's dead. I mean, it's removed from the group, so it can't find a player anymore. We've removed it from the group. So that's, I think, a really great way to make it easy to allow the player to die without having to worry about trying. The other approach would be to try and reparent the camera to the world scene so that it doesn't get destroyed with the player whenever the player dies. I think this is the more elegant solution personally. So the last thing I want to do for this video is just turn off visible collision shapes. I've had them on this whole time because it's useful for debugging, but now we can take hits from the bat, damage the bats ourselves, and there aren't any effects for these things yet, so it looks a little plain, but we'll be working on that soon. That's going to be it. Before we end this video, there are two more small things that I want to address. The first one is that the bat enemy kind of freaks out once it reaches the player because it's still trying to approach them, and it kind of moves past them and flips back and forth really quickly, and that just doesn't look very good. The second one is that our player doesn't have any invincibility frames on their roll, so when they roll through an enemy, they take damage, which kind of makes the roll a little bit pointless. And actually, there's a third one, which is that our player is able to roll in place. What was that? I guess they're not able to roll in place. I thought they were. Oh, I know what it is. They're able to roll in place at the very beginning of the game. That's what it is. So those are the three things that we're going to address. Let's start with the bats. So the problem with the bats is that they have a range, right? So they're trying to approach the player, and we check to see if the player is in that range. But currently the range only has a kind of a range maximum. And so we want to add a range minimum that they have as well, where they stop moving toward the player if they're under that minimum value. So let's create this. We'll call this range max. Or actually, we should call it max range, huh? Max underscore range. And then we should create another export variable before it called min range. And we'll set this one to just 4. That should work pretty good. And then down here, it's going to get mad at us because this range doesn't exist anymore, although it hasn't gotten mad at us yet, so I don't know why that is. It should be throwing an error here. But we want to say if the distance to the player is less than the max range and distance to player is greater than the min range. Just like that. So now we have this minimum range that the bat has, and that should solve our bat problem. We come up to it. Once it reaches 4, it just kind of sits there, which works just fine for us. Now let's address the player's iframes during their roll animation. So click on the animation tree and then go to the animation tab, and we're going to do the same thing that we did during the iframes for the blink animation, only this time it will be in roll. If we come to roll here and we zoom in just a little bit and turn on snap, we want to make sure we select the Hurtboxes collision shape right here. Not any of the other collision shapes, that won't do us any good. It has to be the one on the Hurtbox. Now we're going to key, I'm just gonna key this as disabled. I'm gonna disable it and key it. It's going to create a reset track for it. We want it to do that. And then we'll come to the end of our roll animation. I'm not going to go to the very end because it looks like we have like a single standing frame in the roll animation. I'm going to actually turn the hitbox back on right here on this frame. So there's a little bit of vulnerability at the very end of a roll. I think that's okay. That's just a design decision. You can choose, and you could easily move this around as you choose as a designer. So now I'm going to pause the video, and you can pause the video, and I'm going to do the other roll animations off screen, and then you can do it as well while the video's paused, and we'll compare at the end. Okay, so I've got roll up here, roll right, roll left, and we'd already done roll down, and you can see they all start off with the Hurtboxes collision shape disabled, and then re-enable it at the end. The last thing we need to do is go into our reset track again, and you can see that by default, Godot has set it to disable this collision shape on the reset track. We don't want that. We want the default to be enabled. So essentially, the hitbox is active, or the Hurtbox is active in our reset track. So there we go. That's set up, and our player should be able to roll through enemies now with ease without taking any damage, and that is working correctly. Looking good. Okay, let's fix the last issue, which is just that we can roll at the very beginning of the game, we can roll down. We come into, or roll in place, I should say. We come into here, you can see our last input vector is what is used when we're switching to the roll state, right? We're using the last input vector. So instead of setting this to vector 2.0, we could set this to vector 2.down and see if that solves our problem. So there we go. And yep, by default, the player will roll down. And then of course, you stop in any other place, looking pretty good. So there we go. That's in a really good place now. Thank you so much for watching this video. I hope you enjoyed it and learned something. If you did, be sure to subscribe to the channel, like the video, press the bell so that you'll be notified when I release the next video in the series. And if you have any questions, leave them down in the comments below. I do my best to answer them. Thank you so much. I'll see you all in the next video.